Hello everyone, welcome to today's Knowledge webinar, Additive Manufacturing Capabilities in Creo 7. In this webinar, we'll be exploring the additive manufacturing capabilities available in the latest release of Creo 7. You can seamlessly design, optimize, validate, and run a print check all within the same environment, all within Creo. Today's presenter, Paul Dye, is a member of the Virtual Center of Excellence with PTC, a group trained in giving high-level overviews of all PTC products. He's the best person to be with us today, and he specializes in the area of Creo, aided by his background in mechanical engineering design, and 3D modeling. Knowledge, as you know, is best place to buy Creo, and Knowledge is also changing the way designers purchase 3D software, offering more choices, more freedom, best advice, and faster service. And currently, we're running a promo on Creo Learn. The new Creo Learn online subscription provides unlimited access to all Learn basics and Learn sessions listed in the Creo curriculum guide. And now enough about me. You probably would like to hear from Paul. And so we'll share a screen in a second. So I'll take you over the new additive manufacturing capability with Creo 7. Take it away, Paul.
All right, thank you very much, Barbara. Very good introduction into knowledge and into what we're going to talk about today. So, again, my name is Paul Dye. I am an application engineer here with PTC out of the Virtual Center of Excellence. So our group is pretty much in charge of going over lots of different high-level overviews of all the different products, whether it be Creo, but also into augmented reality with Euphoria, PLM, or product management, or even into the Internet of Things. But today, I want to go over what we have in our additive manufacturing extensions in Creo. And just to go over a quick agenda for what we're going to see throughout this. So first thing I'm going to do is go over some of the different challenges we typically see out in the industry today around people that are building out designs, whether it be for additive manufacturing or not. And then some of the solutions that we really have here in the context of Creo. Go over some of the different capabilities we have there. We'll see a demonstration of some of those different capabilities and a little bit about how that workflow looks, and then wrap up a little bit with the value of it and really how this is going to impact what you do going forward. And so first and foremost, many of the different design decisions that we make are historically driven by the manufacturing methods that we plan on using. Things like injection molding or milling. These things have certain considerations you have to be able to take into account. And what it does is it really limits us in terms of the geometry that we're able to create, where a lot of designs just simply aren't possible to create using the manufacturing methods you might be used to. And it can also be really costly and require a very long lead time to even create the tooling that's needed to manufacture those products. And there's lots of different things, lots of different equipment that's needed to even begin the manufacturing process in a lot of cases. And as the parts that we work with start to increase in complexity, so do those costs, so do the lead times. Everything starts to get a little bit more than we'd like to manage. What we most times end up seeing is people over-engineering designs, just because it would be too difficult or too time-intensive and really just too complex to optimize the part, but still be able to manufacture the model correctly. So what that means is that many of the different things that we'd like to improve upon, things we want to optimize, things that we want to build out, just aren't really reasonable to do because of those different limitations that we normally work around. And what we found is that additive manufacturing can provide a solution to a lot of those different challenges, really all of them. And we've put a lot of time, a lot of money, and a lot of effort into Creo, specifically in the additive manufacturing extensions, to give you all the functionality that you need to start building out the designs with those new world of capabilities in mind. So we can go through and talk around some of those. And one of the big areas that we've had a big focus in is the idea of creating lattices. So this is something that gives you the ability to create some very strong, but at the same time, say very robust geometry, save on material costs, or even just make the design more visually appealing. So lattices in general have been something that simply would not have been possible to create through standard manufacturing techniques, but is something that's a piece of cake not only to design and automate here in Creo, but also create on the 3D printer. You'll see there's lots of different types and configurations you can use here. Everything from more of a 2.5D shape to 3D lattices. So it gives you the ability to create lots of different lattice structures and take out weight, make things a lot cheaper to produce, and still at the same time be structurally sound. So I'm going to go through and show a little bit about what that lattice creation looks like. There's lattices that you end up creating, and once they're built, they're integrated in seamlessly with our different optimization and analysis tools in Creo. So that allows you to not only build out the lattices, but at the same time, start to optimize them depending on different design considerations or different constraints you want to put them under. It's really moving away from those more over-engineered designs, those kind of blocky designs that are just going to pass by the time they get to validation. So moving away from that, and once you've optimized the structure, take it into analysis. See the stresses, see the deformation, check out the temperatures, whatever might be important for you to go ahead and improve that design, really start to optimize towards a much better design overall. And then from right within Creo, be able to do the printer tray optimization. So you're able to do this manually. You can build out patterns as however you want to have these parts arranged in the tray, but also be able to do things like nesting optimization, where the system goes through and optimizes the placement of those parts within the tray. So it just gives you the best possible orientation whenever it's time to go ahead and print those out without you having to manually do that. And then once those are built out, it's all saved as a Creo assembly file that you can still go through and work with later on if you want to. And moving on, if you have more of a 3D metal printer or metal 3D printer, then you can move into working with the Additive Manufacturing Plus extension. And so this is something that starts by giving you, first and foremost, printer connectivity to many different printers that use the build processors through one of our partners, Materialize, which is in just about most every type of 3D printer on the metal side that you're going to work with. So we have, first and foremost, that connectivity. And then once you have the printer connected straight into Creo, also have the ability to manage each 3D printer, add new ones in, look at the jobs being sent to each one, and do that again from right within Creo. What that gives you the ability to do is rapidly define and build out tray configurations very specific to metal 3D printing. And then another capability specific to metal 3D printing is the automatic generation of the support structures. So whenever you're building out support structures for metal 3D printers, or 3D prints in general, there's a lot of different considerations you have to be able to take into account. So we give you lots of different configurations when you're creating the support structures to make sure that they're built out for things like easy removal, heat dissipation, even material savings. It's all the things that are important in the process. And again, this is all things that are being done right in Creo. It's not something that I do a file save as and ship it off to another software and there's somebody else on my team. We don't want to do that. We want to keep all within the same software, all within the same user interface, and keep away from data translations, making sure that every piece of this process of from design to building out lattices to getting it all the way through to printing is all done within that same user interface and same thing looking at all the data there. And it's one thing to talk about it, but another thing to see it really in action. So we can go ahead and switch over now into Creo to see what that looks like. All right, so for our demonstration of the different additive manufacturing extensions in Creo, we're going to be working with the data set that we have from one of our customers that we've worked with fairly extensively in Royal Enfield. So this is going to be a motorcycle assembly that we've been working on. So you can go ahead and open that up here. And this is again being done in the latest version of Creo, version 7.0. And there's a couple different areas that we want to work with here. So let's first start down at the muffler and the exhaust assembly. So if we hide the casing here, we can go ahead and grab one of the internal parts that we want to work with. So this piece here is the start of the sound attenuation in the muffler. And the current design is fairly simple in this case. It may have come from a previous design, and the idea when it was built was probably it's very straightforward to manufacture, right? If you take a look at the section view, it's essentially just a couple holes going straight through a cylinder, maybe something that was extruded. And so that's this existing system and really the start of our exhaust control, but maybe now we want to get something different. Maybe now we have a 3D printer on site, or we're working with a third party. We're going to try out some new designs. And so first and foremost, we'll clear out the center area, and I want to use our latticing capability to see what I can come up with. And lattice structures can range anywhere from very simple to very complex. But the idea is that a 3D printer has no problem creating this type of geometry. So it's going to start simply as a lattice feature here in Creo. And the first thing we define there is the lattice region, which is essentially just the boundary or the area where the lattice is going to exist within. And then from there, we can select the cell type that we want to use. So in this case here, I want to use one of our newer stochastic lattices. This is more of a randomized ball and beam structure going throughout here, which has a lot of cool uses. And with any of these that you'll see, really regardless of what the cell type is, we have lots of different options and parameters that we can change. So we can go through, change the cell size, the nodes, diameters, cross-section, until you're happy with the structure you built out. And once we have that built out, we can visualize what that would look like here in the part. And if you like what you got there, and you could go ahead, accept that, and then start preparing it for 3D printing if you wanted to. And if you don't like it, or maybe you just wanted to go through and try out a couple different things, well, go ahead and do that right within the same feature, right? So if we take a step back here, we can try out more of a 2.5D design if we want to simplify things down a little bit. And it still has lots of options for cell size, the shape, and lots of options in general for exactly how we want to create it. So say we look at this and see, it's a little bit thin. Maybe we want to make that wall thickness a bit thicker, or even round out the inside of that radius. You can simply do that here, and then get that cell and see exactly what it's going to do right as you're building that out. And again, at any point, I can tell the system, show me what that's going to look like overall. And so even after it's created, still be able to work with it, analyze it from there. And another type that I want to go through and try out here is our formula-driven lattice. These are things that we've put a lot of time, and it's really been a big area of research that we've done in Creo to create these lattice types. Again, more specific to metal 3D printing, where they have fully self-supporting geometries. So there's no need to build out complex support structures that require all those different supports to be able to print. So these are really something that is completely changing the rules for what something like this, like a muffler center section could be. And because you're able to create structures that just weren't possible in the past. Something a little bit more like this. Definitely a bit different than what we had with that cylinder with just a couple holes going through it. And if we like what we have here, we can go ahead and accept the design, and it gets built out as a lattice feature. And so that's, again, a design that we could really only manufacture with additive, and it's done by taking advantage of all the advancements we've had in the world of additive, whether it's just for prototype, all the way up to full-scale manufacturable parts. So that's really the first main capability that you get with additive manufacturing is the lattice feature. And what I want to do now and move more into is the printing of the actual parts. So we can go ahead now and move towards the front end of the assembly, or maybe now we're also planning to print out the outer case for one of our sub-assemblies. We'll go ahead and open that up here. And taking a look at the part itself, it's a fairly complex piece. So it normally requires a lot of work to go through and cast and machine all these different features and holes, or even just machine everything from a stock piece of material. And what we want to do instead is use additive manufacturing to create that shape. So what this does, first and foremost, is allow us to work with some different materials that may not have done very well with something like casting, but we have no problem whatsoever using on our metal 3D printer. So the process we're going to go through now and do is building out kind of the start of it by 3D printing the main shape, and then finishing it up by doing some machining just to clean up a few of the surfaces and create some of these features. So what we see here is the completed design after the machining. And so what I'm doing now is rolling back some of those different features and showing the model that we're planning to 3D print with just a bit of extra material that's going to be cleaned off later on. So many of the features that we see here were created using our flexible modeling feature just to offset some of those different surfaces and give us that extra bit of material. So anything we see in yellow there is what's going to be machined down and cleaned up later on. And we just want to print a little bit more than that from the stock piece. Again, just using some standard Creo functionality to build out all those different features. All right, so now what we have is the piece that we're planning to 3D print. Now we can go ahead and start to set up the build tray and the build direction for the print. So first I'm going to set up a plane that's going to act as the base of the print of the build tray that we're going to use. So that's where we're going to go ahead and begin the print from. And what I need to do from here is figure out how I'm going to position this piece in the tray. Because if I'm trying to save on things like scrap, material waste, then I definitely want to go through and be able to cut back on the amount of support material that I'm generating. And the best way that we have for doing this in Creo is with the build direction analysis. So the first thing that this study looks at is the critical and the subcritical angles, where anything that goes beyond those angles is going to require the use of support material. And we can actually have that highlighted on the model, see where some of these problem spots might be. And then from here, instead of us trying out lots of different positions and manually trying to determine the best orientation, we can just simply let the system do that computation for us in this build direction analysis. All right, so now we click compute, and now Creo takes our part along with the critical and subcritical angles, and it's iterating through and figuring out what the optimal position to print this part in. There might be some parts you work with where the optimal point direction is pretty much obvious. It's just more of a boxy shape, might be straightforward. But if you're working with a piece like this, where it's a bit more round, a bit more complex on the inside, or it might not be as obvious to figure out, well, we don't need to. We just let Creo do that work for us. So it will go through all these different orientations until it converges on the solution. And what we get is an orientation that we probably would not have thought of on our own, but this is now going to be optimized for the part that you're working with. So the end result that you get is simply just a coordinate system that we can now use when it's time to go through and print everything. And then from there, we can set up everything for our particular print. So we can go ahead and do that now. Now we're going to go through a little bit of the process of preparing this part and laying it out on the printer tray. Again, this is actually the printer tray that we have out on the shop floor. Right, so we can have that and have that all in Creo, have that linked up to those printers, and then we can send our prints directly from Creo to get printed. So we support direct interfaces with plastic printers through 3D systems, and also metal printers through Materialize, that type of build processor, which really covers a large majority of the metal 3D printers that you're likely going to be working with. Right, and once we have the specific tray and the build tray selected, we can now go through and arrange the parts onto the tray. So this is where we can now take what we did over in the build direction analysis that Creo went through and optimized for us and take that now into our setup here. All right, looks good. So now with that build direction assigned, we can now really go through and determine how the supports are going to be generated. So we'll go through and really say what we have for our self-supporting angles, other parameters, whatever we want to build out there, lots of different options. And then again, right in Creo, generate the support structure. And so it's not something that we're sending off to another program, and having it all figured out there and then trying to translate it back. You're saying right within the same interface, right after you designed it. And what's nice is even if the part changes, even if the printer settings change, you can go through and update all the supports it builds out without any hassle. All right, so we can visualize what that looks like here. And in our case, if we do have something that changes, say we have a self-supporting angle of 45, well, we can switch to a different support structure profile. So you can very easily switch between those two different profiles. So now we have a different angle. Now it's going to be 45 degrees. And with that change, we can go ahead and regenerate the supports. And that's what's nice here too, is now you can have a template set up for one printer, have different settings set up for another printer. And so now based on that build direction and the increased self-supporting angle, obviously now we're going to require a bit more support there. And from here, I'm now able to take that part, take all the support structures, and we can take it through the process of previewing it and visualizing the slice file right from in Creo. So that's a CLI file that we can generate and either share off or just view right here, right in the same interface. So now Creo will go through and generate however many slices it takes to create that design. And then once it finishes going through each of the slices, we then have the ability here to actually display each of those and see each of the slices that go into creating the design. So let's get a little bit of a better view of that. We can switch our orientation to more of a top-down view. It gives us a clear view of what each of the slices are going to look like. We'll zoom in right here. And now we can get a good understanding of the print that we just went through and set up. So what this process allows us to do is spot check and really make sure that we like, or at the very least understand each of the parts that's being printed. And if there's any geometry we want to go through and change, we can go back through and make any of the changes we need to. And that's really one of the biggest things to notice, is that every step that we take in this entire process, it's all right within the same standard interface, whether it's for building lattices, or even starting from a fairly standard part where you do your normal design, and then even taking it all the way through for the preparation for 3D printing. It's all right within Creo. So we start with the base model, optimized for build direction to cut down on the support material, set up and connected to one of our particular printers that we want to print from. We go through and generate all the supports, and then finally take it through here and visualize all the steps here without ever having to leave Creo. So that's something that's really great here. So whether you're building out plastics or even using metal 3D printing, we have these different extensions within Creo for additive manufacturing to take us step by step through that. All right, so that's a little bit about what that workflow looks like here through Creo. And what that does is really give us a lot of advantages going forward and gives us a lot of different value. So first thing, what we've typically seen is very reduced time to market, because you can cut out a lot of the processes that typically require you to get from the part from the design software and the manufacturing. But the additive manufacturing extension allows you to be a lot more quick and almost set up everything right here in Creo and get it into production that much faster. And then we go through and also accelerate our new product introduction, because not only are you trying out a lot more designs much faster, but you're able to try out lots of designs that maybe you only would have thought of about in the past, but are really easy to work with within the context of Creo. And that's really what we want to do at the end of the day, is not only make high quality products, but at the same time, innovate and try things out, try out designs to your heart's content. But you don't have to worry about whether it's going to be able to be milled or casted or anything like that. That's something that additive manufacturing in general really gives you. And at the same time, reduce many of the different costs associated with manufacturing. And that's all from working within additive manufacturing in the context of Creo. Right, so that's a lot of what we've seen here, and obviously a lot of enhancements that we've had in general within Creo. But with that, I can pretty much wrap up for the day, and I can pass it now back over to you, Barbara, and take any questions that we might have. Or again, if you think of anything after the call today, feel free to reach out. We get that answered for you, or anything that you might want to see going forward. But with that, I'll pass it over to you, Barbara.
Thank you so much, Paul. That's a great presentation. I am waiting for questions. If you want to type them in, just go on the question tab and your control panel. In the meantime, I want to remind you of the promo for Creo Learn, which you can find at novage.com. And this is let me show you the page where you can find Creo 7, and you can always call us. Our phone number is on every page of our website, and Novage offers more choices, more freedom, best advice. So give us a call. Hold on, I have one question. Just a second, I'm going to read it to you. Is there a formal relationship between the D feature model specific for AM and the features of the design model? Or is that a manual relationship one manages? What do you think, Paul?
Let me see, could you read that off again? I just want to make sure that
read
I
it to you
understand
again.
completely.
I'll do something else. Actually, I'm trying to assign this to you manually if I can. I'm having trouble. Okay. Is there a formal relationship between the D feature model specific for AM and the features of the design model? That's the question. Or is that a manual relationship one manages?
Typically what we'll see is people just laying out different configuration files for one of your standard part that you want to make, and then you could set up a different configuration model for specifically additive manufacturing. And we'll typically do that with lots of different types of manufacturing, whether it be casting or milling. What we'll essentially do is say we're going to make this configuration specifically for the stock piece. And so what that does is if you have changes to the standard file, you can have those all propagated to that specific configuration that you set up for it at the additive manufacturing. So it's not necessarily manual if you don't want it to be, but if you wanted it to be manual and you wanted to kind of manually set up all those changes, you could do that. But in general, what we'll typically do is have those different configurations set up in kind of a parent-child relationship. Whenever you have the main model, have changes there, those can all be automatically pushed down to the configuration specifically for additive manufacturing. And then that particular configuration only has the specific features that are getting it ready for 3D printing.
Thanks, Paul. I hope that answered your question, Ben. Let us know. Yeah, that it did. So great. If you have any question, we'll hang out another few minutes. Otherwise, I also want to remind you that this session is being recorded and we'll post it on YouTube later on. So if you want to watch it again, share with your colleagues or your team. It's always very useful to look at it together. And that's it. No other questions are coming in. Paul, thanks again for a great presentation. And have a great rest of the day, everybody. Come to noveg.com for any kind of solutions or help. We're always here for you. Thanks, Paul. Have a great rest of the day, and bye-bye, everybody.
Have a good one.